Hi student, good to see you all again in chapter 7, Form 2 Science, chapter 7, Electricity and Magnetism. Today we'll go through part 1 only, chapter 7, Electricity and Magnetism. We'll go through part 1 today, alright. In part 1, the first thing we're going to learn today, alright, let's check the first thing that we're going to learn today. We will learn what is energy. So all of us must know energy is the ability to do work. What is energy? Energy is the ability to do work. Alright. So whenever work is done, energy is used or converted from one form to another. Examples, you can see people use energy to run, plants need energy from the sun to continue living, cars need energy from fuel to move. The light from the bulb is produced by energy. The electrical energy is converted to light energy. So these are the conversions of energy. So we have a lot of forms of energy, alright, sound energy, kinetic energy, electrical energy. Sound energy is transmitted through vibration, kinetic energy is obtained by moving objects. Electrical energy is converted to so many other forms of energy. Electrical energy is converted to so many other forms of energy. We have gravitational potential energy. An object is actually at a certain height from the ground. Elastic potential energy obtained by objects which are stretched or compressed, light energy, nuclear energy, heat energy and chemical energy. So we also have a lot of natural sources of energy, and the one we converted from earth, the sun, the wind, the wave, radioactive substance, fossil fuel, biomass, water, geothermal. So there are a lot of sources of energy. So we start with electrostatic charges. Okay, a neutral object will have equal number of protons and electrons. A neutral object will have equal number of protons and electrons in the body. Electrostatic charges, alright, electrostatic charges, okay, we're going to see how an object is charged. So it's called static charges. So objects are charged through three concepts. Number one, alright, objects are charged through friction, rubbing. Number two, contact by touching a neutral object to a charged object. And number three, by induction, by bringing close a charged object to a neutral object through induction. So this is how the electrostatic charges can be produced. So we can charge an object by induction, friction and contact, right? So if you see the notes here, static electrical charges are electrical charges that do not move. So these are called static charges. They can be produced by friction, rubbing and also induction. Induction is not here, induction. And then we have two basic ideas. When objects gain electrons, they become negatively charged. And when objects are losing their electrons, they become positively charged. So objects are negatively charged when they gain electron and positively charged when they lose their electrons. Okay. Basic structure of atoms, as all of us know, in the nucleus there's proton and neutrons, and there are protons, neutrons in the nucleus, and around the nucleus there are electrons orbiting. So these are the electrons that can actually be lost or gained by an atom. So loss of electron, the atom becomes positive ion. Gain of electron, the atom becomes negative ion. So static charges, we see here, positively charged, loss of electron, they have more number of protons. You see this diagram, positively charged, they have more number of protons because they lost electron. And negatively charged, they have more number of electrons because they have gained extra electrons. And when they are neutral because their number of protons and electrons are equal. So you got 5 protons and 5 electrons. So this object or this atom is completely neutral. So again, loss of electron, they become positive ions. Positive ions are gain of electron, they become negative ions. See, negative ions are. Okay, next. So static charges occur because an object loses or gain of electrons. So they are charged now, alright? And as what we know, that's very simple. When they have the same charges, see, positive, they repel, or negative, they repel. So when they have same charges, they repel. When they have opposite charges, positive and negative, they attract. Negative and positive, they attract. So opposite charges, they attract. Alright. Van de Graaff generator can be used to show the presence of static charges. Due to a continuous friction, induction occur at number 2. The whole metal dome is positively charged. Alright. Then while taking a woolen cloth and a neutral comb, while rubbing, you can produce charges between them. There are static charges here. The comb rubbed with the woolen cloth will gain electrons from the woolen cloth and will be negatively charged, right? So by rubbing we can produce charges. Alright, next, electroscope. This is a device used to determine the type of charges. Very simple. See here carefully this diagram. If you bring a positively charged strip to the metal disc, the electrons are attracted to the metal disc from the gold leaf and the metal rod. This is the metal rod and this is the gold leaf. So when you bring a positively charged strip to the metal disc, the electrons are lost from this area. The electrons will go up. So what happened? This whole area will be positively charged because they lost electron. So same charges between the gold leaf and the metal rod. The gold leaf will diverge. See, this is the gold leaf. It is diverging away. So if you get the picture, if the metal strip is positive, the strip is positive, the gold leaf area also will be positive, same charges. And see here again, you bring a negatively charged strip here, all the electrons will be pushed away because same charges. The electrons pushed away, the whole area will have more electrons now, same charges, the gold leaf diverge again. So the trick here, if this is negatively charged, this whole area also will be negatively charged. If this metal strip or the strip rod is positively charged, any object positively charged, this whole area will be positively charged. And because the rod and the gold leaf are having same charges, it repel away. Because of the gold leaf and the metal rod are having negatively charges, same charges, they are repelled away. So an electroscope can be used to determine the charge on any object, right? Okay, next. If you bring the first charge and you bring in the second object with the same charge, the divergence level here will be increasing. And let's look at basic ideas of static charges in our daily lives. Very simple. Lightning is one of the idea of static charges, where the clouds are highly negatively charged, the bottom part will be negatively charged, and during a collision they transmit or they transfer all the electrons to Earth. The negative charges in the clouds are attracted to the positive charges on the surface of the Earth, so lightning occurs. Okay, basic idea about electric current. Electric current is the rate of flow of charge. The next subtopic here, we're coming in ready. Electric current is the rate of flow of electric charge. Earlier, electrostatic charges, now the flow. So electric current is the rate of flow of electric charges through a conductor. We measure the unit called ampere. So can we measure electric current? Yes, the unit of ampere. What is electric current? The rate of flow of charge. Next one, this is the ammeter diagram. We also have the milliammeter diagram. Since this is ammeter, the pointer is pointing at 1, you've got 1 ampere, or pointing at here 0.5 ampere, or here 1.5 ampere. This is the symbol. Then we have the quantity of electricity, we call it the potential difference. The voltage is the potential difference between 2 points, or the amount of work done to transfer one coulomb of charge from one point to another. Both ways we can listen, right? We can use the way both to explain the potential difference, the amount of work done to transfer one coulomb of charge from one point to another, or we can tell potential difference is the voltage, right, between 2 points. We use voltmeter. This is the voltmeter, this is the symbol, and the unit is still in volt, V capital, volt. Then what is the relationship between current, voltage and resistance? The ability of a conductor to limit or resist flow of electric current. The ability of a conductor to limit or resist. So when you have a conductor, when current flows to the conductor, how difficult is it to flow through? How easy is it to flow through? So the limitation caused by the conductor is called resistance. The unit is ohms. Ohms, this is the symbol, ohm symbol. Alright, okay, these are the symbols of basic resistors. So when you have a circuit, a loop, a circuit, so you have the dry cells, the batteries, to provide the voltage and the current flow through the conductor. This is the conductor, this is the resistance across it. Alright, so the basic formula is V equals to IR. We have this triangle, V equals to IR. So we call this Ohm's law. The relationship is called Ohm's law. So Ohm's law states that the electric current, alright, that flows through a conductor is directly proportional. The electric current is directly proportional to the voltage, provided the temperature and other physical conditions remain unchanged. So Ohm's law states that electric current that flows through a conductor is directly proportional to the voltage across two ends of the conductor, provided the temperature and other physical conditions remain unchanged. So this is Ohm's law. So V equals to IR. So R will be a constant value. Next. We have finished the subtopic, guys. So this is a simple practice. State the forms of energy that exist in each of the following situations. Boiling water, you know, heat energy is there. You can even add on potential. A chicken running, for sure, kinetic energy. A compressed spring, for sure, elastic potential energy. These are the answers. As the clouds move, a lot of electric charges are accumulated by the clouds. Based on the statement above, explain the occurrence of lightning. Lightning is the process where the clouds are discharging their negative charge to Earth. Negative charge, because of the electrons in the clouds, are discharged to Earth because of the surface positive charge. So the transfer is called lightning. And finally, what is the resistance of a car light bulb that conducts 0.025 ampere current when it is connected to a 12 volt car accumulator? So very simple. Use the formula of V equals to IR. So V is 12 equals to I 0.025 times R. So 12 equals to I 0.025 times R. So R is 12 divided by 0.025 ampere. It's 12 divided by 0.025 ampere. So if you take 12 divided by 0.025 ampere, you will get a value of 480 ohms. 480 ohms. Okay, thank you, students. That's all for this subtopic. We'll see you again in the next subtopic. Thank you.